Multiplying matrices. Unlike addition of matrices, when you multiply matrices together, the order that you multiply them is extremely important. Extremely important. For matrix multiplication to be possible, the columns of the first matrix being multiplied must be the same as the rows of the second matrix. If this is not true, then it is impossible to multiply the matrices together. That's the first thing that you're looking for. If it's not possible to multiply the matrices together, it's not possible, there's no solution. So let's take a look at a couple of examples. If you have a matrix, we'll call it matrix A, and the dimensions of that matrix is 3 by 2, and then you have a matrix B, which we'll call that having dimensions of 2 by 3. Then we have another matrix, we'll call it matrix C, that has dimensions 5 by 3. And say I wanted to multiply A and C together. Could you? That's always going to be the first question. Well, let's take a look at what the size of matrix A is. Matrix A is a 3 by 2. Matrix C is a 5 by 3 matrix. Since these numbers right here do not match, remember, this second number in matrix A, that is the columns of that matrix, and the row is this number right here for matrix C, they don't match. So it is not possible to multiply. So, no solution for that one. If you wanted to multiply, let's say instead of A and C together, if you wanted to multiply, let's say instead of that one, let's do C and A together. So instead of A times C, let's change this up and let's multiply C times A. Remember, on the last page I said that how the order is extremely important. So let's kind of write these down. Matrix C has a size of 5 by 3. Matrix A has a size of 3 by 2. So what we're going to take a look at is these numbers right here, they match. Therefore, we can multiply them together. So they match, so therefore we can multiply the matrices together. Alright, so we've decided that we can multiply it. The one thing that I will mention is that the ending size of this matrix, or dimensions, will be a 5 by 2 matrix. And this 5 by 2 right here comes from this number 5 and that number 2. So that's why we've got the size of this matrix is going to be a 5 by 2. So that's going over just if you can multiply them together or if you cannot multiply them together. So even though we couldn't multiply A to C, we could multiply C to A. Now let's go over some examples where we actually have the numbers in there so we can see what we're doing. So if we're given another matrix with actual numbers in there now, say we're given the matrix matrix A, which has the numbers 3, 1, 2, 4, 7, 8. And then I have a matrix B, which has the dimensions 4, 2, 1, 0, and 7, -1. First thing you always want to do is I said, okay, multiply A and B together. The first thing that you want to do is decide, is this going to be possible? Can I do this? Yes or no? And so then you take a look and you say, okay, well, matrix A has 2 rows and 3 columns. Remember, 2 rows, 3 columns, and that's why it's 2 by 3. This matrix B right over here has 3 rows and it has 2 columns. That's why we call this matrix a 3 by 2. So if I wanted to multiply A and B together, the first thing that you want to decide is, can you, yes or no? And in this case, we can. Alright, we can multiply this matrix together. Now the analogy that I always use for this is a pole vaulter. So the way I think about matrix multiplication is when I can actually multiply them together, I just always rewrite them 3, 1, 2, 4, 7, 8, and I'm going to multiply that to the matrix 4, 1, 7, 2, 0, -1. So the way I think about a pole vaulter is that, because matrix multiplication is a lot different than addition and subtraction. Addition and subtraction, remember, you add or subtract the corresponding parts. With multiplication, what we're going to do is we're going to multiply this right here to that right there. And that's kind of why I think of a pole vaulter. Because if you're thinking of a pole vaulter, what happens is a pole vaulter carries their pole, and then when they're about to vault, or in this case perform the multiplication, they stick that pole right here, they stick this end of the pole oops, let's undo this. Let me erase this real quick. They take this end right there when they're doing their pole vaulting and they stick it right into the ground. So what happens is that 2 will line up with that 7, that 1's going to line up with the 1, and the 3's going to line up with the 4. So the multiplication is going to be 3 times 4 plus 1 times 1 plus 2 times 7. And then we are going to repeat that again with the next column. So then we're going to have 3 times 2 plus 1 times 0 plus 2 times a -1. And then I always refer to this step as rinse and repeat. So the 4, 7, 8 gets multiplied with this 4, 1, 7. So 4 gets multiplied to 4 plus 7 being multiplied to 1 plus 8 being multiplied to 7. And then you repeat that process again with the other column over here. And so what happens is this 4 gets multiplied to that 2 plus that 7 is multiplied to the 0, and then you've got the 8 being multiplied to the -1. And the nice thing is when you keep everything organized and you go through here and you're kind of trying to backtrack to see if you did right, if you look inside the parentheses 4, 1, and 7, if you look inside the parentheses here, 2, 0, and -1, they're the same numbers. So that lets you know that you did everything right. And then if you look in the rows, 3 and 3, 1 and 1, 2 and 2. And then 4 and 4, 7 and 7, and 8 and 8. So it lets you know that you kept everything organized. Now your final answer, your ending matrix, is this multiplied together and added. So 12 plus 1 is 13. So remember, 12 plus 1 is 13, plus 14 is going to give us 27. And then repeat that process. 6 plus 0 plus a negative 2 is 4. And then we've got 16 plus 7 is 23. 23 plus 56 is 79. And then we've got 8 plus 0 plus a negative 8, which is 0. And that is what A and B multiplied together give us. There's the matrix 27, 4, 79, and 0.